Now let us revise about the reactions of carboxylic acids. Reactions of carboxylic acids. And the first type of reactions are the reactions involving a cleavage or the breaking of OH bond of carboxylic acid. These are basically the acid-base reactions. So all these reactions proves that carboxylic acids are acidic in nature. For example, carboxylic acids on reaction with reactive metals, it can be any reactive metal like sodium, potassium, magnesium, aluminium, gives a brisk effervescence due to the liberation of hydrogen gas. But this reaction is given by phenols also, the reaction is given by alcohol also. So actually we cannot differentiate whether the compound is carboxylic acid or alcohol or phenol with the help of sodium. But this reaction with sodium only indicates the presence of a hydrogen attached to more electronegative atom. Now second reaction is the reaction with the alkali base, it gives a salt. This is called neutralization reaction. So it gives salt plus water. Now this reaction is given by acid and phenols. The reactions given by acid which are stronger than water. And this reaction is given by acids, alcohols, phenols, even amines gives this reaction. Now the third reaction is the reaction with the baking soda, NaHCO3, sodium bicarbonate. They also gives a brisk effervescence due to the liberation of carbon dioxide which turns the lime water milky. Now this reaction is given by carboxylic acids. So whenever you want to differentiate the carboxylic acids from other compounds, use sodium bicarbonate. For example, to distinguish between benzoic acid and phenol, although both are acidic in nature, phenol and benzoic acid, we prefer sodium bicarbonate test. So we write the test in this form, in the tabular form. So we add sodium bicarbonate. It does not react, it gives a negative test, but it gives a brisk effervescence due to liberation of CO2. And similarly, one more very important example is distinguish between methanol and methanoic acid. Now in this case, many students they use tolerance test, they use Fowling solution test to differentiate methanol from methanoic acid, as methanol is an aldehyde. But aldehyde group is also present in methanoic acid. Like this is an aldehyde group present, this is an aldehyde group present. So we cannot use tolerance or Fowling to distinguish this pair of organic compound. So we use in this case the sodium bicarbonate test. It does not react, negative test, it gives a brisk effervescence. So whenever one of the compound is carboxylic acid, you prefer sodium bicarbonate. It gives a brisk effervescence due to the liberation of CO2 gas. So this is the first category of reaction, and these reactions only proves that the carboxylic acids are acidic in nature. Now second category of reaction is the nucleophilic substitution reactions of carboxylic acids. Nucleophilic substitution. And these reactions involves the replacement of the OH group of carboxylic acid by some other group. This is the group called G. Now these are examples of nucleophilic substitutions. For example, this is alkanoic acid given. Now, first reaction, as you know, we can replace the OH by Cl, as we have already discussed in alcohols, using either PCl5 or SOCl2. We can replace the OH by Cl. Now, this is called acid chloride and is named as alkanoyl chloride. So, IC acid has been replaced by YL chloride. This is an acid derivative. Now, second reaction is the reaction with ammonia. Now, first on reaction with ammonia, it gives a salt. But salt on heating, this is ammonium salt, and on heating it decomposed to give another acid derivative called amide. This group is called amide group and is named as alkanamide. Alkanamide. So, oic acid has been replaced by amide in this case. Now, the next reaction is the reaction with P4O10. This is basically the dehydration of carboxylic acid, phosphorus pentaoxide and heat. It results in the formation of a N-hydride. Now, this is called alkanoic anhydride. Alkanoic anhydride. So, acid part, the acid as a suffix has been replaced by anhydride. And the last reaction is the reaction with alcohols. In the presence of a sulfuric acid, it forms an ester, the sweet smelling compound called ester, and the side product is water. And this water has to be removed to prevent the backward reaction. To prevent the backward reaction. So, as soon as the water is formed, you have to remove water from the right hand side. Now, these are some examples. Now, this is given a propanoic acid. Propanoic acid. Now, on reaction with the PCl5, it forms a propanoyl chloride. Propanoyl chloride. Second is on reaction with the P4O10 and heat, it forms a propanoic anhydride. This is called a propanoic anhydride. And on reaction with the ethyl alcohol, in the presence of a sulfuric acid, it forms a sweet smelling compound called ester, and this ester is named as ethyl propanoate. So the group directly bonded to oxygen will come as a prefix. In this case, it is a ethyl, and the acid part in the alkanoic acid, we replace IC acid by ATE. So it was a propanoic acid. Now this propanoic acid becomes a propanoate. So IC acid has been replaced by ATE. Now the third category of reaction is the reduction of carboxylic acids. Now the carboxylic acid group can be reduced to form either a primary alcohol using lithium aluminum hydride, or we can reduce this carboxylic acid to alkane. This is a complete reduction using 6 moles of HI and red phosphorus. So acid can be reduced to alcohol, acid can be reduced to hydrocarbon. For example, this is acetic acid. So on reaction with the 6 moles of HI and red phosphorus can be reduced to ethane, and on reaction with the lithium aluminum hydride can be reduced to ethyl alcohol. Now the fourth category is the reactions of carboxylic acid as a salt. Reactions of carboxylic acid group as a salt. For example, this is carboxylic acid on reaction with sodium hydroxide. It gives a sodium salt, and the sodium salt can be changed into alkene with one carbon less. So this group has been replaced by H using soda lime. So this is called decarboxylation. It's a loss of carboxylic acid group, and soda lime is a mixture of NaOH plus calcium oxide and heat. But this sodium salt can also be electrolyzed. So on electrolysis, which is known as a Kolbe electrolysis, it gives RR. It's a hydrocarbon. So the new bond has to be formed between the alpha carbon atoms. Now the fifth reaction is the reactions of the carboxylic acid involving alpha hydrogen, and the alpha hydrogen can be replaced by halogen, and the alpha halogenation of carboxylic acid using halogen, where X can be chlorine and bromine, in the presence of red phosphorus is known as Helmholtz-Zielinski reaction. Very, very important reaction, or we write simply HVZ reaction. But the reaction is given only by carboxylic acids containing alpha hydrogen. For example, this, you have two alpha hydrogens in this case. So in reaction with X2, in the presence of red phosphorus and water, it gives RCHX and COOH, where X can be chlorine and bromine. And once this X is obtained, it gives all the reactions of the alkyl halide. So there are two examples now. The first one is this: acetic acid on reaction with chlorine in the presence of a red phosphorus, H2O gives a chloroacetic acid. Now we discuss one more example in the form of a question. Now this is propanoic acid, and on reaction with bromine and red phosphorus, it gives bromine at the alpha position, and once this bromine is obtained, it gives all the reactions of the alkyl halide. For example, on reaction with hot and alcoholic KOH, it undergo alpha beta elimination to form a propanoic acid. Now the sixth is the reactions of the benzoic acid involving benzene ring. Benzoic acids involving benzene ring. Now these reactions are called electrophilic substitution reactions, and this carboxylic acid group is meta-directing, deactivating, and exerts a minus R effect. So these are the two reactions. One is the bromination of benzoic acid. The bromine comes at the meta position. So bromine in the presence of FeBr3, so catalyst is required as a group is deactivating. So it gives a meta-bromo benzoic acid. And the second is the nitration of benzoic acid using HNO3 and the sulfuric acid. The nitro group comes at the meta position, and the compound is called meta-nitro-benzoic acid. So these are some reactions of carboxylic acids, but HVZ reaction is very, very important in this case. So this is all about the reactions of carboxylic acids.